Hey everyone, today we're going to learn how to determine when a function is concave up. To do that, we need to understand derivatives and how they tell us about the shape of a function. Let's break it down step by step using the function y equals a third x cubed minus x squared minus 3x minus 6. By the end of this lesson, you'll know exactly how to find when a function is concave up. Before we start, let's go over the rules we'll use to differentiate. Today we'll be using the power rule, the most simple for this function, which states if we have x to the power of n, its derivative will be d on dx, x to the power of n, which we've already got. It'll equal n out the front, the number, to x n minus 1. So that's the rule we're using today. Okay, so to find the first derivative, applying that rule, we can do it step by step here. So firstly, the derivative of 1/3 x cubed is, so we times the 1/3 by the 3, which is just 1, x, and as you can see here, we minus 1 off the original number, so that's 2. No need for the 1 now, so that's just x squared. For the second part, we've got minus x squared. Same again, times the front by 2, so we have minus 2, and then minus 1 off the original, so x, just x, because that'll be 1. For the third part, minus 3x. To derive this, so there's nothing there already, so we just cancel out the x. So that just equals minus 3. And for the last part, minus 6, there is no x, so we don't include that, that's 0. Okay, so that leaves us with y equals x squared minus 2x minus 3. That's our first derivative, y dash. To find the second, we derive again using the same rule. So here, x squared, this is for y dash dash, x squared turns into power down the front, 2, and then minus 1 off there, so x, minus 2x turns into minus 2, similar to this one, and then once again minus 3 will just be 0. Okay, so now we're left with y dash dash equals 2x minus 2. Okay, so to determine concavity, a function is concave up when the second derivative is positive, so when y dash dash is larger than 0. So let's solve. 2x minus 2 is more than 0. 2x is more than 2. Therefore, x must be more than 1. So that's one way to test or determine when the function is concave up, or we can equal this 2x minus 2 to 0. 2x minus 2 equals 0. 2x equals 2. X equals 1. And then to test from there, we can draw a table here, x f dash dash x, and we put this in 1 here, 0 on one side, anything smaller than 1 on that side, and then anything larger on this side, so we can just do 0 and 2. We know this is 0. We put 0 into y double dash, it equals 2 times 0, so 0 minus 2. If you put 2 in, 2 times 2, 4 minus 2 is 2. So it's concave down on this side, flat there, and concave up on that side. So we know that anything past 1, anything larger than 1, we concave up. So let's recap. We took the first derivative to find the slope. we took the second derivative to analyze concavity, and we set y double dash larger than 0 to solve for x to determine whether the function is concave up or not. In this case, the function is concave up for all x above 1, sorry. That's it. Now you know how to check for concavity using derivatives.